Hi everyone, welcome back to 3.5. We are talking about complex zeros of polynomials, and this is going to be a long example. Long because I'm going to go through a lot of the trial and error stuff. I do know the answers, so I could just jump right to it, but I kind of want to go through all the process that you would if you were just, here's the problem. So here is my polynomial, 3x to the fourth minus 2x cubed minus x squared minus 12x minus 4. And we are to find all of the zeros. So the first thing I would do is notice it is a fourth degree polynomial, which tells me I'm going to have 4 zeros. Now all of those zeros may or may not be the same. We could have 4 zeros all being the same, or we could have different pieces. But we're going to start applying all these things that we've learned. So, first thing I'm going to do is take a step back. And when I take a step back, I see 5 terms, which for me, in my limited knowledge, I have no bells and whistles going off. So that doesn't help me at all. So I'm like, okay. So I'm going to start using some of the processes that we learned in 3.4. So I'm going to be looking at all those possible rational zeros that we have. And I'm going to see that my p is either going to be a plus or minus 1 because I'm looking at the 4, plus or minus 4, or plus or minus 2. My q comes from the 3, so I have the plus or minus 1 or the plus or minus 3. So all possibles, we're going to have plus or minus 1, plus or minus 1/3, plus or minus 4, plus or minus 4/3, plus or minus 2, and plus or minus 2/3. So we've got lots of possibilities out there. Now I'm going to look at, remember my Descartes' rule of signs. Rule of signs. So looking at my original piece, you'll notice that it started out positive and then it went negative, and then it stayed negative. So we have one sign change, which means we will have one positive real zero. Okay, and remember it would then decrease by even integers, so the next one would be a negative. Well, we can't have negative zeros, so that means we do have a positive real zero. Okay, does not say it's going to be a rational one. It could be like the square root of 2, but these are going to work for us, so it is going to be one of our rationals. Okay, but in the real world, we aren't guaranteed a rational zero. We will be guaranteed a real zero. So it could be an ugly square root of 2. I'm also going to look at what f of negative x, or p, I should say, p of negative x looks like. And so I'm substituting in a negative x wherever I see an x. So if I put a negative x and raise it to the fourth, it still stays positive. If I take a negative and raise it to the third, it becomes negative. That negative times this negative makes it positive. The even exponent stays the same. The odd exponent changes the sign. So we see something that looks like that. Now the number of sign changes I have here, we see 1, then another 2, and 3. So we have 3 sign changes, which means we have 3 or 1 negative real zeros. Okay. And if you think about it, we have 4 total, so we could have 1 positive and 3 negatives. That would work. We could have 1 positive, 1 negative, and the other 2 could be complex. I don't know. So I'm just going to start trying some. Like I said, the ones I like to try most of the time are going to be the nice easy ones. Also noticing if I just stuck in 1 into there, so I'm thinking in my head the 1s, the 2s, the nice easy numbers, substituting 1 just in the here as it sits. This would be 3 minus 2 minus 1 minus 12. Already there's no way that I'm going to get 0. So I'm going to possibly look at something a little different. So I'm going to try just off the bat, I'm going to try -1 and see what happens. And I'm going to put my coefficients in here. I'm doing synthetic division because it's a little faster. And if it works, I know what the result quadratic is. So bring the 3 down. I multiply and add. I multiply and add. We multiply and add. We multiply and add. Okay, so there it is. But I want to remind us of that upper and lower bound piece. I just got lucky here, that you'll notice that these alternate in sign. So we went positive, negative, positive, negative, positive. By that upper and lower bound theorem, this is telling me that -1 is a lower bound. So I have no negative values, negative zeros that are smaller than -1. So I'm not going to get the -4, the -2, or the negative, I guess I don't have any other ones smaller than that, or the -4/3. Okay, so I mean I can try some of my other ones. I'm going to try a positive one just to see what happens. I've tried a negative. I could try fractions, so my -1/3 or my -2/3. We could do it. Oh, sure, why not? So that you guys can see I'm not scared of fractions. So let's try the -1/3. Hopefully my multiplication isn't so ugly that I get really ugly numbers, but we'll see. So I drop this down. I multiply, which is going to give me a -1, and we add. I multiply, which is going to give me a +1, and I add. I multiply, and then I'm going to multiply and add. We get a 0 as a remainder, so that means that -1/3 is a 0. So we're happy. Okay, and even further, we know what is left. Because we were at a 4th degree, this is going to be now a 3rd degree, and it's going to be 3x cubed minus 3x squared minus 12. My x term is not there. And even further, I notice that I can pull my 3 out, and I'm left with x cubed minus x squared minus 4. So my zeros now are going to come from just this piece here. So I'm no longer going to be seeing those 3's involved. So my 2/3 are now off the list. My 1/3 is off the list. I'm left with my 4's and my 2's. And we already tried +1 early in the beginning. So I'm going to try +2. And I'm just going to go into this piece, but I'm going to go into 1, -1, 0. Don't forget the x piece. And the -4. So bring this down, multiply, and we add, multiply, and we add, multiply, and we add. So this now tells me that x equaling 2 is a 0. So now I have 2 of my 4 zeros. And what I have left is a quadratic, which I can continue my methods, but I know how to find the zeros of a quadratic. I will first of all try to factor it, if at all possible. So two numbers that multiply together to give me 2, that add together to give me a positive 1. Does not work. So I'm going to need to go to the quadratic formula. So that tells me that x is going to be, reminding us of the formula, okay, is going to be a negative 1 plus or minus b squared minus 4ac all over 2a. Simplifying it down, so that's going to be 1 minus, that's 8, all over 2. It's a negative 1 plus or minus the square root of a negative 7 all over 2. And if we want this in terms of complex form, that a plus bi, we're going to split this up as a negative 1/2. We'll have two answers, one being positive, one being negative. That square root of that negative is we're gonna see that I pop up, square root of 7 over 2. Or if you really like, to make sure it's that a plus or minus bi, we'd see it there. But you'll notice that we did get a conjugate pair. We got one positive, one negative. There's nothing wrong with the first term being negative. The change is going to be in between the real part and that complex part. Hopefully this example helped bring back some of that 3.4 stuff in with the 3.5. So our zeros, just to kind of put them all together, we had a negative 1/3. We had the number 2. We have a negative 1/2 plus the square root of 7 over 2i. And we have a negative 1 over 2 minus the square root of 7 over 2i. And we have all found all 4 of our zeros. I'm going to stop the video here and come back with a couple other littler problems, because I do want to show you a few other things in this unit as well.